Welcome back to Packet Brew. Today we're covering OSPF LSA types and stub areas, critical concepts for understanding how OSPF optimizes large networks. We'll focus on the essential LSA types including the special type 7 and show you how stub areas reduce database size and improve performance. Hit subscribe for advanced networking content. What are LSAs? LSA stands for Link State Advertisement. Detailed reports routers share about network topology. Key LSA types will cover types 1 to 5, standard LSAs, router, network, summary, ASBR summary, and external, and type 7, NSSA external, the special case. All routers collect LSAs in their link state database, but stub areas filter certain types to reduce overhead and improve performance. Essential LSA types. Types 1 and 2, local area information. Type 1, router LSA. Every router's business card, interfaces, costs, neighbors stays within area. Type 2, network LSA. Multi-access networks, Ethernet, generated by designated router only. Types 3, 4, and 5, inter-area and external. Type 3 is the summary LSA. ABRs advertise networks between areas. Area 1's networks into Area 0. Type 4 is the ASBR summary. ABRs advertise how to reach external route sources in other areas. Type 5 is the external LSA. ASBRs inject external routes. Internet, BGP. It's domain-wide. But there are problems introduced by Type 5 LSAs, since it's flooded everywhere, creating huge databases in large networks. The solutions for this are stub areas. OSPF stub areas. Stub areas solve the LSA overload problem by filtering unwanted LSAs. Starting with the regular stub area, it blocks Type 5 LSAs, external routes, allows only Types 1, 2, and 3 LSAs. It gets default route via Type 3 LSA for external access. The next is totally stubby area. Blocks Type 3, 4, and 5 LSAs, allows only Types 1 and 2 LSAs. It only gets single default route for everything outside the area. Here are some things to note for stub and totally stubby area. Routers in the stub area have to be configured as stub routers. At least one ABR should be present in the area. There must be no ASBR within the stub or totally stub area. Area 0 cannot become a stub or totally stub area. If you really need external routes in your stub area, you can configure it as a not so stubby area. It uses Type 7 LSAs instead of Type 5. NSSAs can also be configured as totally not so stubby area if you want to block Type 3 LSA. Here's a real example. A branch office with ISP connection but wants stub area benefits. NSSA allows local external routes while blocking others. Type 7 LSA, NSSA external. Type 7 LSAs are NSSA's secret weapon, external routes that stay local. How it works. ASBR in NSSA creates Type 7 LSA, not Type 5. Type 7 floods within NSSA area only. Area border router translates Type 7 to Type 5 when advertising to backbone. Other areas see it as normal Type 5 LSA. Key benefits of NSSA. NSSA gets local external connectivity. Still blocks external LSAs from other areas. Reduces link state database size compared to normal areas. Perfect for branch offices with ISP connections. LSA and area quick reference. LSA Type 1 is the router LSA. It's allowed on all stub types. LSA Type 2 is the network LSA. It's allowed on all stub types. LSA Type 3 is the summary LSA. It's only allowed on stub areas but not on totally stubby areas. LSA Type 5 is the external LSA. It's not allowed on all stub types. Lastly is the LSA Type 7, the NSSA external LSA. It's only present on NSSAs. When do you use the different areas? You use the normal area for full LSA database for maximum flexibility. You use the stub area to block external routes, reduce database size. You use the totally stubby areas to minimize the database further. NSSA are used if you want to have local external routes with stub area benefits. That's LSAs and stub areas in 5 minutes. Like and subscribe for more OSPF deep dives. Practice this in the lab to master them. See you next time.